Hello kids, in today's class, we are going to start with the new topic prime factorization. So in the last class, we have understood that what are the prime numbers. Again, I am repeating, prime numbers are the numbers which have only two factors. One is the 1 and the second number is the number itself. So if I say that 5 is a prime number, so its factors are 1 and 5. So every prime number has two factors, 1 and the number itself. And then we learnt about the composite numbers. They are the numbers which have more than these two factors. Like in the case of 14, we have 1 as one of the factor of 14, 2 is one of the factors, then we have 7 and the number itself, that is 14. So if there is any number which has more than these two factors, then that number is a composite number. So all these concepts we have done in our last class. Today we are going to learn about a concept called as the prime factorization, which means that we have to find the factors of a given number to the point that we are left only with its prime factors. Okay, so what I mean to say here is, I will tell you with the help of one example. I am taking example of the number 15. Okay, so kids, when we see the number 15, we know that it is a composite number because it has more than two factors. Okay, so now what I am going to do here is, I am going to break this 15 into its factors till the point we are left only with the prime numbers. Let's see how we have to do it. So 15 has two factors, 5 and 3. Right? If I multiply 5 with 3, I will get 15. Correct? So 5 is one factor and 3 is the another factor. Now further, I am going to break this 5 into its lower factors. So kids, if I see here, what are the factors of 5? The factors of 5 are nothing but 1 and 5 itself. Similarly, the factors of 3 are nothing but 1 and 3 itself. So that means we cannot further break down these numbers. Okay, we cannot further break down 1, we cannot further break down 5, same for 1 and same for 3 also. And also we see here 5 and 3 are the prime numbers. So what we can say here is that we have broken down this 15 to the prime numbers, to the smallest possible prime numbers, and after which we cannot further break them, because we know that we cannot further break prime numbers. So what are the factors of 15? I can pick from here. 1, the last available numbers we have are the factors. 1, then 5, 1 is already here, so I'm not repeating, and then 3. So these 3 are the factors of 15. Okay, this we have done by the prime factorization method. Okay, similarly we can do this example 20, or let's take 36 here. Okay, we are given with two example 20 and 36. I'm trying to tell you 20 from here only. What are the factors of 20? We can write down 20 as 2 and 10. Okay, and then to this 2, we know it's a prime number. We can either leave it here. We can again write this as 2 and 1. And 10 can be broken down into 2 and 5. So if you see this row now, all these numbers are the prime numbers which cannot be broken down further. So what are the factors of 20 if I see from here? They are 2, 2 and 5. These are the factors from the prime factorization method. Okay. So same we can do for 36. Let us do 36. So kids, there are many ways to do it. Like in this example, they have taken 2 and 18. We will do it from here also, but I am telling you another one. We know that 4 multiplied by 9 will give us 36, right? 4 into 9 is 36. So now we have two numbers, 4 and 9. So if I see 4, 4 is not a prime number. It can further be broken down into 2 and 2. We can break 4 into 2 and 2. We can break 3 as 3 into 3. And if you see this complete row, 2, 2, 3, 3, they all are the prime numbers which we cannot break further. So from this one, from this tree this is called as factorization tree. Okay, so if I see this tree, the factors are 2 multiply by 2 multiply by 3 multiply by 3. So all these are the prime factors of 36. Okay, so here what I have done, I broke 36 as 4 into 9. But if you will see this example, they have done it like 2 into 18, which is also true because 2 multiplied by 18 will give us 36. So next what they have done, 2 can be written as 2 only. Okay, don't count it as 2 and again 2. They are not 3 2s. This is only 1 2 which they have broken down like this. Okay, and then other one is 18. So 18 can further be broken down into 2 and 19, and then 2 as is and 9 into 3 and 3. But if you will see the end result of it, it is same. 2 into 2, 3 into 3. Okay, and then again there is another method also. I can also write 13. See kids, what I'm trying to tell you here is we can take any two factors and then we can break them. It's not necessary that if 36 is here, you have to take 2 into 18 only, or you have to take 4 into 9 only. Okay, so if I take for 36, I can also write this as 3 multiply with 12. Okay, so if I see it as 3, 3 is the prime number which cannot be broken down further. So this is the last end of this branch. I can keep it like this. Now coming to this branch, we have 12. I can write 12 as 2 multiply by 6. Again, 2 is a prime number. We cannot break it down further. So this is the last branch of this tree for 2. Now coming to 6, I can write this as 2 multiply by 3, right? So 1, 2, this one, 3. These all are prime numbers which cannot be, again, we cannot break them further. Now, so if you see this picture, what are the factors of 36? From this branch, we have 3. From this branch, we have 2. From this branch, we have 2 into 3. So that means we have 2 times 2 and 3 times 3, which is same as what we have done for with 4 and 9 as factors. Okay, so what I mean to say here is we can pick any two factors, but we have to drill them down, break them down to the smallest prime numbers. This is called as the concept of prime factorization. Okay, that we have to reach to the prime factors of the given number. So I hope that you have understood this concept. And with this, let us start with the exercise 4B. It says, first question is, say true or false. Explain the reason for your answers with examples. The product of two prime number is also a prime number. Okay. So one prime number I am taking as 2, another prime number I am taking as 6, and I am finding the product. This is product, multiply. So if I multiply, I am getting 6, but 6 is not a prime number. So this means it's a false statement. Correct? Next, there is only one composite number in the 80s. So kids, we have done this. Also, if I give you example, 81 and 82, both are composite numbers. So this is also false. Next is all numbers with 2 in ones place are composite. This we have done, that except 2, all the other numbers are composite. So this is a false statement because it is also considering the number 2 only. Okay, so the number 2 is the prime number, except the number 2, all the other numbers which have 2 at the unit place, or you can also say ones place, is composite. D part we have all odd numbers are prime numbers. So I am taking one odd number 9. It is not prime. It has two factors, 1, 3 and the number itself, more than 2 factors. Similarly, if I take 15, it has 1, 3, 5 and 15. Okay, so more than 2. So both of these numbers, they are odd, but they are not prime. So this statement is also false. Last we have is a composite number cannot have 3 factors. So we have seen the example of 9. It's a composite number. It has 3 factors. So what we can say here is all the given statements are false. Next question is question number 2, where we have to use any method you prefer to factorize these composite numbers. So we can use any method. We can use the common factor method also, which we have done, and we can also use the prime factorization. So since question number 3rd is based upon the prime factorization, so let us do this question with the other method. Okay, so question number 2, I am picking the B part, which is 60. So let us break down. For 60, we will start with 1. This is one of the factors. Then 2 is also a factor. 3 is also a factor. 4 is also a factor. 5 is also a factor. 6 is also a factor. 7 is not a factor. 8 is not a factor. 9 is also not a factor. 10 is a factor again, right? 12 is a factor. Then 13 is not, 14 is not, and 15 is there. Yes, right? So after 15, what we have next? We have next as 30, 20. Sorry, 20 is one of the factor. Then in the table of 20, from 20 to 30, if you see, then 25 is also not a factor here. The next we have is 30. After 30, we have 60 directly. Okay, so all these numbers, they are factors of 60. Correct? Similarly, let me do one more part for you. Another you can take as homework. Let me take 63, F part. This was B part. Okay, now I am picking 63. So let's do. We have 1, 2 is not a factor, 3 is a factor, 4 is not, 5 is not, 6 is also not a factor. Then 7 is a factor, 8 is not, 9 is a factor, 10, 11, 12, 13 is also not a factor of this. And then what we have next is 31 is not 31. We have 21 as one of its factor. Okay, and 21 is one factor, and 27 we have 20. Let us see if we get 27. 27 is 3. No, will not get. Yeah, so 27 is also not a factor. We have 21, and then after 21 we have 60. 7 into 9 and 9, then we have 63 only. So these are the numbers which are factors of C. That is 63 here. Okay. Now, rest of the parts you can pick them as homework. They are very, very easy. Let me do question number 3, where we have to do the find the factor, but this time we have to use the prime factorization method. Okay. So for prime factorization, what we have to do is, I'm picking the first part. Okay, let me pick 75 here. What we have to do, we have to break this into small factors. So 3, if we do 7, if I multiply, if I try to find the factors of 75 using 5, we know that 5 is one of the factor, right? And then after 5, 15 is the another factor. Okay, and then 5 is a prime number, we cannot break it down further, but 15 is a composite number, we can break it further into 5 and 3. And if we see this, these are the prime factors which cannot be broken down further. So we have 5, this 5 and this 3 as the factors. Okay, these are the factors of 75 using the prime factorization method. Also, you can write them this as 1 into 5 and all, and we can include 1 also here. This is B part. Now I am picking the C part here. C part says 21. So 21 has two factors, 7 and 3. And both of these, they are prime numbers. They cannot be further, we cannot break them further. So 7 and 3 are the factors of 21. Okay, so this is how, kids, we have to do these questions, and rest questions you can pick as homework. They're easy. Okay, so this is all about the prime factorization method, and next we have